This week we're going to be talking about hacking web servers. So we're going to talk about describing various web applications, talking about web application vulnerabilities, and looking at the tools that are used to attack web servers. So writing software, it's impossible to write a software without bugs, right? You have various functional and cyclomatic complexities as you increase the amount of code that move exponentially. You cannot have a large enough team to get every bug out of every piece of code. And especially if your piece of software relies on other libraries, you can't depend on other companies to remove and get rid of all the bugs in their code. Those bugs are potential security vulnerabilities, and they are ultimately used to exploit, create exploits for web applications. Web applications, just like regular software applications, have bugs, and they all have a large user base. The larger the user base, the more attractive the target, and the large user base makes some of these bugs bigger problems, especially when we talk about SQL injections and buffer overflows. There is it's a lot easier to exfiltrate data through a web application, especially those that are posted on the internet versus an intranet application. They're just very attractive targets. So there's two types of web applications, static and dynamic. Static pages literally are just markup and JavaScript and CSS that are served, and that's it. There's no interaction with the server besides handling HTTP requests. Dynamic web pages, on the other hand, include server-side code. So, for instance, you might have a form on the web page, and you type in username and password. That passes it off to server-side code written in various languages: PHP, Ruby on Rails, Python, ASP.NET, either VB or C#. There's tons and tons and tons of various server-side applications, even Perl and CGI. But anyways, that code on the server handles the data and then sends back information to the client. So those are the two main types of web application components. A form element, if you're not familiar with HTML, it allows for an end user to submit data that is typically posted to a server using the HTTP post request. And web servers would then take that information and process it. And that's where attackers look for these vulnerabilities, is in the processing. Can I use a text input element on an HTML document to perform a SQL injection, because the server-side code takes that input in a text box from an HTML form and then places it inside of a SQL query that then gets sent to a server? Did they properly escape that data? Did they not? How are they handling it? Is there potential for a buffer overflow to even type executable code and inject it in there? So this is obviously form elements, any sort of communication where either get or post variables are being written to. This is where security testers want to start fuzzing. Here's an example of a web form. You see here, I'll highlight it. You have input text name, username, and password. Why their type is. If you don't put that, it won't be hidden from the end user. Both password and text, if you're not familiar, type of text boxes. Password boxes are masked. In either case, they're both sent back to the server, and the server then handles these. It'll get a post variable called username and a post variable called password, and it might have a SQL query that checks that user name and then takes the password and gives it a salted hash and then applies that to the database to see, is this a valid user, and then pass an authentication token back to the user to say, yep, you're authenticated, you're clear. But it's that SQL query that the server runs in the backend that becomes important. Here's an example of what that form looks like on the web. CGI, you've probably heard of it. It's called the Common Gateway Interface. it handles moving data from the web server to the web browser. This is when we talk about dynamic web pages. Many of the scripting languages on the server side are built around CGI. And CGI's main goal is to determine how the web server passes data to the web browser, so it relies on whatever scripting language you're writing in. You can have PHP run as CGI, Perl run as CGI, C and C++ run as CGI. It doesn't really matter. It's just essentially how does your programming language interface with the web server to ultimately get data back to the end user. Here's an example of Perl. We're going to respond back to the end user. We're going to say, okay, web browser, we're passing you data that's HTML data. So your content type is a MIME type that's relayed back to the end user. It's the string name of the MIME type. And then after content type is the content body. And here it's hello security tester. So that's an example of a response that a dynamic language using CGI might pass back to the browser. There's a lot of third-party libraries. Some are server-side, some are client-side, some are both. Spring, JSF, Angular, Yeoman, Sass, and Vaden. The problem with a lot of these third-party libraries is they themselves rely on a number of third-party libraries. I had a project recently where it was using Angular, and it had over 1,000 dependencies. When you have a single dependency, you're relying on every developer of each of those dependencies to ensure that they have proper security practices when writing code. The more dependency you have, the more risk you have. And this, again, just like when you're looking at the supply chain during purchasing, during development, you have to look at what's called the security development life cycle. You have to perform threat modeling. You have to say, what risk am I taking on by using a specific package? Who develops that package? Is it state-sponsored? How often is that package updated? Are there many CVEs associated with those packages? You have to be super careful. But third-party libraries, they're growing in popularity, but that may make many applications more vulnerable. If everybody's using Angular and there's a 0-day for Angular, that makes every single website that uses Angular vulnerable. Active server pages, ASP. The latest version is ASP.NET Core. This is just another type of dynamic web programming language. It basically allows C# and VB.NET to be used. Here's an example of the older versions of ASP.NET. Newer versions use the Razor format, which I was on the Razor team at Microsoft for a while. Redesigned it. It's no longer. I mean, you can still use older versions of ASP.NET, but no longer uses the syntax. Older versions used VBScript and JScript. But this is very important if you're going after web pages that are typically vulnerable. Older ASP web pages, not even ASP.NET, classic ASP is a great target. Yes, Microsoft does not want users to be able. Yes, because again, you wouldn't, if you're writing in PHP, you wouldn't see this part right here is translated. Let me highlight it. This is translated by the server. A client would never see this, and this is where you want to go after. You don't see the code as a security engineer. You're on the other side. You see the output from the server, but this is where processing is done. And this is where you want to go after it. Just like where you would go after an executable on the desktop, certain pieces of code, this is the code that you want to go after. This other markup doesn't really matter unless you're trying to go for a browser exploit. Apache Web Server. Another version of server software. So again, Apache Web Server isn't the programming language, but it's the daemon. It's the web server program that's used probably the most widely on the internet. IIS is next. It works pretty much everywhere and everything. You've heard of WAMP or LAMP stacks. So LAMP is Linux, Apache, MySQL, and then Windows is Windows, Apache, MySQL, and PHP. Those are your most common stacks that you'll see all over the internet. That's typically what's used in terms of your platform, which is Linux, your web server, which is Apache, MySQL, which is your database engine, and PHP, which is your server-side scripting language. So when you're using scripting languages, there's lots of scripting languages. VBScript and JavaScript are examples. Scripting languages can run both in the client side and server side. Not all run on client side and server side. For instance, JavaScript can actually be used as a server side scripting language. For the vast majority of the time, it's used as a client side scripting language. But when we talk about Angular or Node.js, a lot of that JavaScript code runs on the server side. PHP is another language that is used, widely used. Facebook has always been built on PHP, for instance. It's one of the first languages I learned. Extremely popular. It's been around for a long, long time. Here's an example of PHP code. Again, this part right here is what gets executed on the server side. So let me do this real quick so you get an idea. That to green. So all of this, the green and the yellow, run on the server side. And what gets passed to the client, so what the client sees, let me fix this, is what's in green. So the server processes all of this, it reads the line of code in yellow, and then by the time it gets to the client, this is all it sees, the client. That echo statement was the code. So just an example of kind of how that works. Cold Fusion, I hope you, seriously, if you're a developer, I hope you never have to write in Cold Fusion. Not widely used anymore, but excellent in terms of exploitable code. So it's an older technology that's still out there. And if you're looking for an entry point into an organization, look for some Cold Fusion web pages. Again, here's an example of some Cold Fusion code. This right here, this tag, just like before, I've been highlighting all these tags. This is processed by the server. The end user doesn't see it. VBScript, lots of vulnerabilities and widely used. So something that, an opportunity for you to attack. Now this is what we're showing here is client side. So if you're looking at this in the browser, you'll see this, right? You'll see all this code. So even though this is what's output on the web page, when we talk about client-side scripting languages, VBScript is a client-side scripting language. Now, with the deprecation of Internet Explorer in favor of Edge, you're really not writing a VBScript anymore for a lot of consumer-facing applications. However, on the enterprise side, you're going to see a lot of VBScript still. JavaScript, probably the most widely used, both on the client side, definitely most widely used on the client side. It's starting to get there on the server side, but most of the time you're going to see this on the client side. And again, if you open up web page source, you're going to see this whole piece of code. But what gets written to the screen is here's an example of, well, if this code ran as is, you're going to see nothing because all this is within a function. If you then having to modify that. There we go. So then if you called chastise user, you would see an alert. So you like breaking rules, and then this would fail because there's no CMD button anywhere in this code. But so this is an example of really bad code that doesn't work. It doesn't do anything, but it does show you kind of the syntax. Oh, here we go. It's continued. Maybe if I looked at the second page. All right, so if you click this button, we'll just delete my... There we go. All right, so if we look at the second page here, maybe if I flipped and looked at it first, I would have known. So here's an example. You'd see an alert. You'd see a command button with JavaScript. All right, connecting to databases. I talked about this before. This is what gets you in a lot of web pages. The whole point of a web page is to show data, right? And if you have a lot of structured data, you're going to be using a database engine like a MySQL or Microsoft SQL Server or Oracle or PostgreSQL. You're going to be using a SQL engine in the background. SQL engines are typically connected to using ODBC. ODBC is a standard for interface connections to databases. And pretty much every language supports some sort of ODBC connection. And that's what gets you connected to the database. Now, there's an older set of interfaces called OLE, Object Linking and Embedding. Faster, more efficient, and more stable than ODBC, correct, but it's not typically what people use unless you're designing specifically a desktop application on a Windows system. So here's some examples of some OLE database providers. ActiveX data objects. You want to know someplace to hit, it's ActiveX, because here's the problem with ActiveX. If you have an ActiveX control on a web page, it essentially makes your web page a desktop application. You have full executable access to the operating system, and this is why Flash would always get attacked, because essentially if you run Flash, you're saying, hey, I am going to distribute this fully fledged web application through my web page and give you access to the end user's PC. Now, with the institution in Windows Vista and above of integrity levels and user access control, and the low integrity level that basically encapsulates API calls that the Flash would make, it's helped, but it hasn't solved the problem. ActiveX and applications that use ActiveX, such as Flash and Java, provide an excellent entry point if you're looking for vulnerabilities and ultimately an exploit. Again, yeah, many platforms can be used to design a website, but if you're looking to control a web server, you want to use these technologies against your target to do what? To either deface the website, destroy the database, exfiltrate the data, encrypt the data, and sell the contents either back to the end user or to other people, gain control of user accounts, perform secondary attacks, or gain root access in order to gain access to other more critical systems on a network. OWASP, so Open Web Application Security Project, is a nonprofit that looks for web vulnerabilities. They have their top 10 list that they put out all the time that talks about what are the biggest risks. PCI DSS, which is the payment standard, all the card manufacturers got together and they said, we don't want the government to regulate us in terms of cybersecurity. We want to do it ourselves. So, and that's the PCI industry group. They got together and built PCI DSS. So if you want to do business with Visa, MasterCard, American Express, anybody, you have to conform to the control sets for PCI DSS based on the amount and type of transactions that you do. But all PCI DSS in the end is built around a lot of it OWASP. So what are the biggest risks to web applications? You have injection vulnerabilities. So I mentioned that before. SQL injection. If there's a built-in SQL query in server-side code, how can I use inputs on a web page to modify that? Authentication flaws and weaknesses. When I talk about how can I masquerade as another user or impersonate another user, that's one type of attack that I might want to partake in. Cross-site scripting, you have site A and site B. I want to be able to inject code in order to perform an action from my site B to site A. Insecure direct object reference. So do I have the ability to modify objects on the client or server side in order to make them do things that weren't intended? Security misconfiguration is pretty self-explanatory. Sensitive data exposure. Am I giving end users access to other users' data when they're not authorized to access that data? Access control at the function level. So again, am I permitting users who aren't authorized to perform certain functions do those functions? Cross-site request forgery. Can I inject code onto a website in order to masquerade as the current user session in order to do something to their account on another website? So for instance, if I'm on example.com, can I inject code to gain access to the user's session to twitter.com? Using components with known vulnerabilities. I talked about this before, and I'm just surprised it's so low on the OWASP list. When you take on a dependency, when you're writing code, you're essentially taking on all the risks of that dependency. And when you're using something like Angular, where you're importing hundreds or thousands of other people's packages, do you know the development practices of those projects? Do those developers follow the security development lifecycle? They have your same security standards because you're taking on every risk that they have. And unvalidated redirects and requests. So essentially, if you receive a redirect or request, are you tying it to an authenticated user or not? The WebGoat project by OWASP, it helps security testers learn how to do vulnerability testing. A lot of people use WebGoat, so we're going to show you some examples. Here's the start page. This is an example of how to handle, for instance, looking at inputs. Here's an exercise for handling AJAX XML injections. And here's another exercise. So if you want to learn about web testing, WebGoat's a great example, great place to go do it. There's two types of testing, both static and dynamic. So static looks at the compiled code or the source code itself. It allows, there's advantages to both and disadvantages to both. Static application testing lets you find out, okay, look at the source code. Does every function has an access level tied to it? Are there potential for buffer overflows? I can run a static tester that says, okay, all my variables, am I properly making sure that we are not allowing data over the size of that variable type to enter that variable itself, leading to a buffer overflow attack? The static testing looks at the code itself. Dynamic testing, oftentimes you'll hear the word fuzzing. You run it to see how the application operates in the real world with real world data. So you'll have applications that, let's say you have a website and takes input data. It'll run that website 1,000 times and put 1,000 different inputs, maybe some with letters, some with numbers, some with various symbols to see what errors come out. And then you go and you fix it. You want to run both in order to gain a full picture of your application security. So when you're a security tester, what are the questions you have to ask? You have to gather some information first. If you want to secure a web application, you need to know how that application operates. So does it have a database? What type of database is it using? Is it using MySQL? Is it using Microsoft SQL Server? Does the application require authentication? What type of authentication does it use? Is it using JavaScript web tokens? Is it using cookie-based authentication? Is it using OpenID? You want to ask that kind of stuff. What are the authorization mechanisms? Remember, authentication and authorization are two separate things. Is it static or dynamic pages? And if it's dynamic, what are the languages? What's the web server type? What language are being used, both on the client side and the server side? What devices use the web browser? Is it using technologies like ActiveX that run executable code? How does data flow in the application? Is it encrypted at rest? Is it encrypted in motion? These are all questions that you need to ask. And then platform security and configuration. There's lots of different technologies that can be used, like we said, about web applications. And when we talked about footprinting before, you want to find out all the information you can about the web server. with specific applications that are being used. What are the vulnerabilities? Are there any CVEs, any recent 0 days? And as a security tester, you take advantage of those, right? You want to make sure that you are going after all bits of information in order to get a full picture of the security and risk footprint of that website. Authentication and session testing. So oftentimes applications require another server to authenticate users. So how is that a token or a session ID is generated? How is that passed along? How is that used? The issue with HTTP is it's stateless. So essentially all of these servers and systems are adding state to a stateless system, which in and of itself provides for the potential of vulnerabilities. The system wasn't designed, HTTP wasn't designed to do the things we're doing today. Newer versions are, and it's been, changes have been made and the system has been modified to support it. But when it was designed in the early 90s, it wasn't meant for this. So you have to go through and ask, how are tokens passed? How is encryption handled? How are users authenticated? How is the state passed along from server A to server B? How are tokens and logins and passwords secured and transported? These are all really important questions you have to ask. And then we talked about authorization, how it's different from authentication. So authentication gets you in the door. And then now that you're in the door, what do you have access to do? What things are you allowed to do? You bought the ticket to the carnival, but are you allowed on the Ferris wheel or are you not? So again, authorization checks your privileges. What do you have access to within the application? And you can't, this is not where security through obscurity works. You can't just obscure a URL to enforce access controls. You have to build it in on the server side. Input valid. So we talked about SQL injection. This is where input validation comes in. I have a username and password field, and instead of a username, I put single quote, semicolon, drop users. Right. I'm going to drop the users table. I'm going to wreak havoc on the website. You shouldn't be allowed to type in SQL queries into any field and have them run. You shouldn't be able to type in, let's say I found out PHP was the backend language. You shouldn't be running exec, for instance, in PHP, and then I can take an input field, type in code, and my code will be executed. Input validation issues, again, can lead to disclosure of data, alteration, or destruction. If I can drop a database table or elevate my privileges, or masquerade or mimic another user by typing in some code into input, that's a really, really bad thing. And again, security testers, SQL injection, number one on OWASP. It's very common. So here's an example. Select star from user where table username equals tick mark or 1 equals 1 and table password equals blank. This is a great example of I can inject comments, I can inject code. So you might have a select statement that you run, but I can use the input to basically inject whatever I want into the code to even turn a select query into something that drops a whole database or drops a table. Input validation, you should be stripping strings of text and special characters that could do things. Like, for instance, you don't allow double dashes, don't allow tick marks, don't allow single quotes, don't allow double quotes. Strip all that out, or if you have the ability, convert them to their equivalent Unicode code, their HTML equivalent. So like greater than symbol is ampersand GT, semicolon. Convert it. Convert the whole string to base 64. Do something, but don't let the code in there be unfiltered. You want to filter it out. Error handling. Error handling in and of itself isn't bad, but the issue is you might be sharing too much information back to the end user. So for instance, let's say you have a username and password field and you're accepting input, and you've done some input validation, but I come up with a way to mess it up just a little bit where your web page throws an error. And that error could reveal the structure of your database, how you were doing the input evaluation, how you were doing the string stripping. It can reveal enough information where I can then tailor my attack to make it work the next time. So you want to make sure that you're not sharing any of that information with the end user. Cryptography testing is interesting. You need to ask yourself, when you have not only cryptography, but like random number generation, salted hashing, remember, there's no such thing as a truly random number in PC. You don't have an atomic random number generator where you have an atom that's throwing off at random intervals, various alpha particles that you could then capture, the time period, generate a random number. We're not doing all that. We're doing what's called pseudo-random number generation, which is based off of mathematical functions that simulate randomness but aren't truly random. And pseudo-random number generation is often built around what's called a seed value, which is typically a time value, a tick mark from the Unix epoch. So, 1/1/1970 is the initial time period. How many tick marks from 1/1/1970? And then that is passed into a function, and that function gives you a random number. But if I am able to figure out what mathematical function you use to generate that random number, or I can simulate the period of time, for instance, let's say you generated user passwords, and I can figure out that you were using Microsoft's random number generator as part of .NET, and I know your server, I know the exact time down to the millisecond that your server generated that number. I can generate that initial password for another user again. So again, we both have access to the same function. I just need to know what function you use. This is the same for cryptography. Cryptography is using pseudo-random number generators. And your vulnerability here is time. If I can figure out not only time, but any inputs that you put into that function, I can output the same result. So you have to be super careful with cryptography and random number generation that you're doing it securely. Business logic testing. You need to take a look at all of your user flows. This goes back to authentication and truly authorization. What is a user allowed to do? Okay, they got their foot in the door. They are authenticated. Now, what are they authorized to do? And you have to look at every step in every single workflow and make sure that every step of the workflow double checks the user's permissions. Client-side testing. Obviously, client-side code is going to be visible to the client. But is there anything in your client-side code that reveals information about your server or how your server is handling data that I can exploit? So, for instance, your input filtering, are you doing it on the client side or the server side? You should be doing it on both, because if you're just doing it on the client side, I can then go and exploit that on the server side to say, oh, well, you're only checking password length on the client side. Well, I can just edit your JavaScript code. Your server can't enforce it once it's on my machine. So you need to make sure that the appropriate functionality is on the client side, and that when it comes to security, you're also doing it on the server side. There's a number of tools that are used by web attackers and security testers, so we're going to talk about these. Obviously, Kali is filled with various tools. You can install new tools using apt-get. There's Firefox and Chrome, and Microsoft's offerings have developer tools. Usually you just hit F12 and they're in there. Burp Suite and Z Attack Proxy. So Burp Suite, there's a number of testing features. You can perform a man-in-the-middle attack, intercept traffic, manipulate requests and responses, and Z Attack can do that as well. So here's a screenshot of Burp Suite. Basically, it's acting as a proxy server, a man in the middle. It's receiving a request, it's modifying that request and sending it back to the user, or receiving a request from the user, modifying it and sending it back to the server. WAPD. It's a web application vulnerability scanner. It doesn't look at your code. It tries to look at cross-site scripting, SQL injection, server-side code fuzzing to inject data into whatever. We'll take the data and you see what happens to your server. WFetch is a GUI tool that looks at the status of your web server. It takes a look at HTTP headers, the various authentication modes that you're using to look for various vulnerabilities. So here's an example of WFetch. So all these, again, are tools that you can use for various steps in the web application testing and fuzzing process. So what did we talk about this week? We looked at web applications, various platforms, ASP, CGI, how web servers work, the difference between dynamic and static web pages, web forms, basically how is the end user getting data to you, various web applications technologies, and if you're on Windows, you can install IIS. It's built in already, so just go to your system applications. You can add IIS, play around with it yourself. But remember, because there's a lot of potential users on web applications and a lot of data, there's a lot of potential vulnerabilities that could have damaging consequences if exploited. And when you're looking at security tests on web applications, there's tons of considerations you have to look at. Looking at the OWASP top 10, looking at SQL injection, most importantly, you got to be super careful, especially, like I said, when applications interact with those databases. And there's lots of tools out there for testing. Lots of tools that are free. Lots of tools you can download yourself. Charles, Proxy, Fiddler, Burp Suite, WAPD. These are all, and OWASP again with their WebGoat for practicing your skills. These are all examples of how you can get good at and understand web application testing. That's it. If you have any questions, let me know, and have a good week.